Good morning, everyone. Hope this is my first Zoom talk, so be prepared for some mistakes from my side. If there are questions anytime, please just submit them. I try to answer them live. I think it makes much more sense in the flow of this presentation. Today's talk is about how we measure architectural qualities and how architecture itself can have an impact on living conditions in its own and the industry around it. So before we go into the detail, let's make just a proper mindset in the background. So all of you know that we have proper tasks to tackle at the moment. We have climate change with all of its impact. We have emerging cities all over the planet because, of course, the countrysides are not livable anymore. And with this emerging cities, certain issues with architecture are on the rise. And, of course, social conflicts come as well. This leads not only to migrations, but it also leads to densification issues, and it leads to further stress on architecture itself. This is not the first time issues like this happen. We just need to go back like 150 years, where we had the last mass migrations in the Western civilizations. I mean, most of you know all the stories with immigrants to the US. And this came not with climate change in the background, but with further industrialization. And this, maybe those of you with architectural background know this building. Industrialization also impacted architecture. So this is a metaphor many speakers use, this whole industrialization thing in comparison to this new kind of industrialization we face at the moment with artificial intelligence and machine learning. But what have we done so far with this in architecture? I mean, we started to 3D print really abstract shapes. But the question is that all? Is this really the peak of what we could do with architecture? And of course, it is not. I mean, this whole architecture domain is so hungry for innovation at the moment that we need to take a look into neighboring issues to find out what are the driving forces behind this innovation and where is this whole endeavor going to lead. So let's start with transport. I mean, with industrialization, the impact on transport was obvious. I mean, we had for the first time, we had railroad tracks and we had mass transportation, mass public transport. And suddenly it became possible to cross large distances very fast. Nowadays, we have a similar thing. I mean, with artificial intelligence, we face the individualization of transport. So, and the famous car industry is becoming obsolete. One needs to remember that this whole journey of individualization and self-driving cars started only 15 years ago. So this was the Starper challenge in the Mojave Desert. And back then, none of the vehicles managed to drive a straight path through the desert. We all know the videos of different robots moving. So, and this is during the same time span. So on the right-hand side, you see the newest child of Boston Dynamics with his parkour capabilities. And on the left-hand side, there is a fuzzy video of one of the Toshiba robots, which wasn't able to climb chairs 15 years ago. And there was much more development through industrialization or bordering setups. I mean, 150 years ago, we had antibiotics, and nowadays we are cloning humans. 150 years ago, we started broadcasting for the first time, and now everybody is a broadcaster. We had for the first time more or less real-time communications with telephone, and now communication is a permanent status of each and every one of us. And when we look into these innovations, we find out that there are certain enabling innovations which lead to an impact cascade. And well, with industrialization, it's obvious the most impact was made, this enabling innovation was with the Watt machines, with the steam engines generating power. So force was delegated from humans to machines. And nowadays the same thing is with those kind of GPUs, where we can more or less delegate our mind capacities to the computer. We have neural networks, we have machine learning, we have really proper setups, and we can use them now to generate really, really exhausting mindsets. Of course, automotive engineering is one of the most advanced engineering setups, and there they use these kinds of tools already. So in automotive, you know, you have this, all of the simulation setups, you have evidence-based design, you engineer on the computer. But what about architecture? I mean, today we measure everything. We measure, this is a picture of CERN, we measure the smallest particles in the universe. We measure the most trivial things you can think of. I mean, we measure each and every step we are doing. But we are not measuring architectural quality, which would be obvious. I mean, just think of 20% of our Western GDP is based upon building industries. More than 50%, almost 60% of Western civilizations are already living in cities. More than 2/3 of worldwide CO2 emissions are directly or indirectly related with building industries. So, and if this wouldn't be enough, more than 40% of employees are going to be let loose due to digitalization in residential, in real estate industries during the next 20 years. So this is a big topic, and digitization will lead to this major change there. So how would we start measuring stuff there? There is research, at least the tools that Archilyse are based upon, stemming and developed during the last 30 years. So nowadays, we do not need sensors to tell us where people are going. We have proper models from cognitive science. This is predictive behavior simulations. And we can tell you that, for example, in the top middle picture, there are going to be high traffic zones within an office. This is a nice thing. I mean, in the top left image, bottom left image, you see, for example, the distances to an exit. So we can calculate how far is it somewhere. We can also simulate noise issues. We can simulate wayfinding complexities. And we can simulate so many things already during design phase or even before building, that you have a proper basis of knowledge in order to optimize architecture. How does this look like in detail? So back in '96, Bill Hillier had this idea and published a Space is the Machine, and the topic was called space syntax. Maybe some of you are familiar with it. So the underlying idea is that humans are nothing more than further developed apes. So we are still instinct-driven in our wayfinding tasks. So we try to minimize our exposure and we try to maximize our field of view in order to be safe and to feel safe. So we are not these rational humans who just look for the shortest path. We look for the path, or we walk the way we feel most comfortable. And he used lots of students sensing and checking how people are walking, and he did proper evidence-based design and made a proper mathematical models on how people move. Back in the days, everything there was just two-dimensional. So nowadays we have research partnerships, and what you see in the end is one of these outputs we generated. Archilyse, this is raw information from our side. You will never find this openly available. And we make this accessible to our research partnerships in different Ivy League schools. So what we do is essentially we generate voxel clouds throughout the building in a grid size of 5 centimeters. And for all of those 5 centimeters, we calculate different view conditions. And then you can either use an MRT viewer, as you know from the hospital, to split and to move your point of view through the building. But you can also, and this is much more powerful, use this data to correlate it with some data of your statistics and to do proper prediction models. This looks then, in this case, looks like more of those setups. You have medical grade sensors. You measure, for example, heart rate variability, skin, electrical skin conductivity, and so on. And then we can directly measure how people feel in certain built environments. And we can measure architecture-induced stress or level of comforts and so on. And currently we have research partnerships with ETH, the University College of London, and the Royal College of Art. And they made multiple of those studies, and they're doing multiple of those studies. They then relate those measurement points to our simulation points. And from then on, we have proper models of predicting biofeedback or predicting how people are going to feel in this environment. And this is the most crucial point. I really can't highlight it enough. We have the technical infrastructure and we have the data infrastructure to predict how architecture is impacting people. And by having this capability of measuring the impact, we have the tools needed to optimize architecture. So for the first time, architecture becomes now an engineering science rather than an art, because we have the tools to decode this complex, this complex setup of architecture. So there's this one takeaway message of this talk. I want all of you to remember: architecture is going to turn into an evidence-based decision-making process. So we collect data, we combine this data with certain statistics, certain numbers, and out of this convolute of data, you can do better design decisions and better planning decisions. So now, how are we going to use this at the moment with our customers on the market? So for example, we have maps of whole cities where we take the whole building and we calculate what you see from each square meter in all the buildings of a city. So how much greenery do you see? What's the noise impact from the outside? What are sunlight conditions throughout the year? And all of those infos more or less impact the way you feel. And you can then do a proper heat map or a proper map of a city telling you where are you most probably going to feel better, where are you most probably going to be more stressed. The next step is we use machine learning to make it easier to onboard this whole process. So for example, at the moment, we work with one of the largest asset managers here in Switzerland. We go into the archive, we take the floor plans, we use scanners to convert these floor plans into PDF files. And then again, we use machine learning to turn those floor plans into proper RFC models automatically. This is something that was not feasible 5 years ago or even last year. This is brand new tech. And this shows you the power of machine learning within architecture. And now we go one step further. We take those 3D RFC models and we position them in a 3D model of the environment. And this then allows us to go into each and every room of a building and look into 1 square inch or 1 square centimeter fields. And for each of those grid points, we then calculate again, what's the percentage of greenery in your field of view there? How much sky can you see? What are the sunlight conditions in the evening, in winter, in this area? What is the noise issue from the outside? But you can do much more. You can do different compliance checks automatically. So we can detect which kind of space do you have for different standards. We can check how many guests could you host. We can check how many positions of beds are feasible, how child-friendly an apartment is. But you can also do this for office spaces or for commercial, for retail areas. So in retail space, we can tell you where do you see which product in a shelf. In the office space, we have a simulation telling you where can you see how many faces, lots of faces of your workmates in a distance where you can talk to them verbally. So more or less team workability. You can also predict where you're going to have solar glare on your displays, or where do you have better connectivity within a room, or what would be a better meeting room. And we can correlate lots of those simulations to make totally new ones. For example, for a meeting room, it would be good to have a nice view. It should be bright, but it shouldn't be too bright because you don't want it to overheat. And even in case of overheating, you would want to be able to open the windows. But if there is a high traffic road next by, you would not be able to do so because it would be too loud. And all of those effects, all of those complexity of architecture, we can now model mathematically. And in the end, now it's becoming really powerful or boring. Essentially, it's the same thing because we turn all of those fancy heat maps and all of those fancy results into spreadsheets. And these spreadsheets now, these rows and columns of data, they give you the power to do proper evidence-based decision-making in architecture. Because before, you were only just looking into the availability of certain features, if there's a balcony, or if there is an elevator, or if there's still a bed. But now you're able to measure qualities. I mean, a really good example I always like to use is the balcony, because where in default setups, you might know that a balcony has 4 or 14 square meters. It gives you no idea about the functionality or the quality of the balcony. So now we are able to tell you automatically that on this balcony, you have place enough for 2 sunbeds. 3 people could have a barbecue there. You have winter, in winter, you even have sunlight during the evening. You look into the greenery. You are not next to a high traffic road, and. And all of this information is then aggregated into a single number by comparing it to all the other balconies in the neighborhood. And we can tell you that this balcony belongs to the 15% of the best balconies of the city, of the 20% of the worst balconies. The same thing is essentially done for teamwork, accessibility in offices, for meeting rooms, and you then only need to weight those qualities simulations can deliver, and you can properly compare different layouts, and you can do really proper evidence-based decision making when comparing architecture. Of course, what we are doing in Switzerland is in the end always a little bit financial driven. So the first use case for all of this information was to do better estimation models. So with our features, the prediction of rental revenues is twice as accurate. So we can tell you with twice the accuracy where you can achieve higher prices on the market, or where you should charge lower rental prices in order to reduce vacancies. And if you sum up everything our experience has shown us so far, our experience with our large customers like Swiss Life or Archilyse, is that we can increase revenues onto profit by 3%. You can also use this information not just for pricing tags, but you can also use it for star ratings, for make marketing more intuitive. And the definitions is everything what is relevant to yourself or to your target group. And one of our largest successes this last year was that we were able with our features to show that the quality of a floor plan is much more relevant than just the rental price of a floor plan. And with this, we even made it to the yellow press here in Switzerland. A short video now of one of our customers, how the stuff is going to go online this winter already. So we are going on marketplaces with this information. You can then easily access it, and people are going to be informed about the qualities of architecture, much more intuitive. And on the other hand, on the B2B side of our business, also the onboarding into those tools is going to be more easy. So essentially, you're going to have drag and drop infrastructure on the web. You drag your IFC models or your floor plans, and you're going to be to automatically get into proper dashboards, giving you proper environment for decision making and proper environment for side-by-side comparison of different designs, of different layouts, and of course of auto fitting if you're in the office plan. So the division underneath, if you want to see how architecture related decision making is going to happen in 5 years, you only need to go to one page. It's called Kaggle. This is one for data scientists. And this is going to be the future of architectural decision making. Everything totally transparent, everything totally measurable, and everything really, really agile and lean. I hope as an outlook, this is sufficient for you today. And if there are any questions, I'm more than happy to answer it. Thanks a lot.